by converters. And we have plan file, which was generated by router. So we have the assignment, then we can use micro simulator to simulate the movements. And it has several outputs. Here is the like a flow chart of the simulation steps in micro simulator. I think it's very self-explainable, so you can read it when you go back. And here are some parameters that you may want to specify in the control file of micro simulator. I don't want to read them. Here are all the possible outputs. In the version that you run in your homework, for your homework, I only used the first two outputs, summary file and snapshot file. But actually, micro simulator can generate a lot of output files. The first one, summary file. Last time I named it as performance.csv, but starting from today, it will be called link delay because it's a slang that was used in Transim's world. So we call it link delay. We have link delay and we have snapshots, and we can generate other files. For example, here is an output called a problem file. So if micro simulator finds any problem, it will output this problem to an output file. And this output file can be visualized using this arc problem tool. So you can see where in the network is having the biggest number of problems. And here are some parameters of fidelity and limit. So you can refer to the user manual when you go back home. Okay. So very quickly, I introduced three tools: convert trips and router and macro simulator. You have already run Transims. If you think you already know Transims, then you are completely wrong. That's just the start. The essential thing of Transims, is feedback. In Transims feedbacks, in most literature or most projects, we divide the feedbacks into three stages. The first stage is called router stabilization. The second one is called micro simulator stabilization. And the third one is UE that we talked about in the last lecture, which is the goal to us. So this is the hardest part. Why do we have three feedback stages? In the first stage, which is called router stabilization, the purpose is to distribute traffic more logically before simulation. So in the first stage, the micro simulator is not involved. The second stage is called micro simulator stabilization, which is used for debugging. And the third one is called user equilibrium. And you know what user equilibrium is. Before we talk about the procedures, I first have to introduce three more tools. And they are of very similar names. So I hope you can remember them. The first one is called plan sum. All these tools are dealing with plans, so that's why they all start with plan. Plan sum is a tool to estimate travel times on each link using VDF. It's similar to micro simulator, which can also produce link delay file. But in plan sum, the link delay or travel times are predicted using the VDF volume delay functions that I introduced. Okay. The second one is called plan select. In plan select, some households are selected from the whole household set for rerouting, and it's to be explained. So it's for selecting plans. Plan sum is for estimating the travel times. The third one is called plan preparation. And this tool had been used in your last homework. And I used that only for sorting. But plan preparation can do two things. The first thing is sorting. In Transims, the plan file can be sorted in two ways. Either by the traveler's IDs or by the start time of each plan. By default, it's sorted by the traveler's IDs. By micro simulator, the plan file needs to be sorted by the start time of each trip, of each plan. So that's why we need to sort the plan file. That's the first function. The second function is listed here. We can use plan preparation to merge two plan files. So we have one main plan file, another plan file to be merged. Then we can merge the plans from another file into this file. So just compare the difference and merge them into this. So this is for merging and sorting. Please take a last look at it and try to remember it. So I can introduce this thing. Plan select has several control keys, and these control keys have to be explained now. We said we want to select some plans. Select some plans. But how do we select some plans? We can have three criteria to select the plans. The first thing is called random selection. So I just randomly select, like for example, this 10% of out of the whole plan set. That's the first option. The second option is the selection based on V over C ratio. V over C ratio is the ratio of volume over capacity. Okay, volume over capacity. So we compare the links, and each link has an V over C ratio, or each path has an over C ratio too. Then we can use this V over C ratio criteria to select some plans. So that's the second option. For this option, we have three keys to be defined. For example, the selection, the VC ratio. If we define the VC ratio as 1.5, then only the plans with V over C ratio larger than 1.5 will be selected. And the selection percentage, out of this path, the plans which have 1.5 over about 1.5 V over C ratio, 50% of them will be selected. And this key defines the maximum percent that can be selected. So totally, you cannot select more than 10% of the total plans. Clear? All right. The third option is to make a selection based on time difference using the link delay information. So we have a plan. In each plan, we have a time. We have an estimated travel time. But if we use the link delay information, we can get the real travel time. I mean, the travel time we can get from the link delay. If these two times are different, for example, are having 10% or more difference, then it can be selected. Then we can define a minimum time difference, maximum time difference in minutes, and we can select how many percent of them, and we can specify like this, the maximum percent selected. So this option needs 5 keys to be defined. Okay. Now I want to show something. Before I show something, I have to introduce something, these things about DOS. Okay, so actually when I was very young, these are common sense. I mean, when you talk about computer, these are the common sense. But nowadays, a lot of people are only knowing about Windows or Mac. So I have to introduce DOS first. The first thing you want to do is type CMD. This is a command window. In a command window, you can type commands, execute commands. The first concept I want to emphasize is path, including absolute path and relative path. So for example, this is your drive D. If you create a new folder called A, then the path of this folder is D colon /A. So this is the path of this folder. If I create a new file here called 1.txt, Then the full path of this 1.txt is d slash a colon slash a slash 1.txt. So this is the absolute path. Okay. So if I enter that, I can open this text file. In command line mode, we can see our current working path here. This is our current working path. If we want to change to drive D, then we type D colon. And we can use a command called dir to list the directories and folders. And we can use another command called cd to change directory. For example, cda. So don't be too bored about this. So now our current path, working path, is D, is the A folder under the root of D, and we can use the command dir to list all the files, all the folders here. So if our working path is D colon slash A, then we can use 1.txt to represent this file, to indicate that file. This is called the relative path. But if we say d column slash a slash 1.txt, this will be the absolute path. This is absolute path. Okay, relative path and absolute path. You use cd to change your current working directory, and if you want to go to upper level, upper level is called dot dot. So if you type cd dot dot, then you go back to the upper level. Okay.